So we've got a table of physical characteristics. Pardon the appearance of the last column. We'll say that that's appearance. And basically what I'm saying is that's not helpful because they're all gray powder. I just sort of scrawled something. My apologies. I can't find my good stylus, and this one sticks. I don't like it. So if you had to develop a procedure for separating these three substances, and actually I'm going to make this vaporization point. Boiling point and vaporization point are about the same, but pardon? Solubility, SOL. SOL, solubility. So, my first question, if you're given a mixture of all three of these things, and I don't want you to yell this out, I want you to talk about this together. Do you have any options for separating these things based on solubility? So talk to one another. Because I'm going to tell you that there are at least 3 pathways to do your first separation here. There are 3 correct answers. Cool. So you and your table come up with 1 correct answer to get your first substance separated out. Just focus on separating 1 for now. Okay, so 3 correct answers. One of them would be this. You heat that stuff till C vaporizes. You're left with A and B. Anybody do that?
If you heated it, you'd be left with B and C.
Oh, yep, sorry. I had that backwards. I make mistakes all the time, and I'm fine with admitting it. Okay, so heat it to 112, drive off A as a vapor. You get C and B left behind. Okay, how many of you took that route? Okay, and that is one of the 3 possible routes. If you take this route, how do you figure out how much C there or how much A there was? This is the method you used in your lab. You're looking at the actual loss. You're looking at a loss of mass. So this is a totally valid way to separate it. The catch here is if you want to preserve A for some reason, if you want to keep A, this doesn't get you A. A goes out into the environment. But if you don't need A, if you just need to get rid of A, it's a good way to do it. Has anybody here ever made maple syrup? Anybody here ever eaten maple syrup? Okay, so here's the problem. When the sap comes out of the maple tree, it is a mixture of sugar and water and other compounds. The goal in making maple syrup is to separate the water from the sugar. You do that by boiling. Do you capture that water? No. And, side note, don't ever try to make maple syrup in your kitchen at home when your parents are not home. Because it'll do terrible things to the entire inside of the house because you don't really want to release that much water vapor in your house, especially not if you have wallpaper in the kitchen. Not that I found this out the hard way when I was 15. So don't do that. You're separating components of a mixture and you're not recapturing one of them. That's fine if you don't need it. Did anybody have something that looked like this? Did anybody have something like that? Where you mix it with water, filter it, A and B end up in the filtrate, C ends up in the filter. How many of you did that? Okay. So in this case then, if you need to preserve all 3 of the components of your mixture, this is a good method. Now it's a little more cumbersome because now you have to dry the A and B to get rid of the water. So you can boil that off.
Wait, A would boil off anyways in the water.
No, 110. Water's 100. You would be controlling that very carefully.
I was thinking 200 was the water's boiling point.
We're in Celsius. Nope. Celsius is 100. So we're gonna dry. We have to dry that mixture of A and B if we're going to further separate them because right now they're both dissolved in the water. They're both soluble. we would have to be very careful. I didn't do attendance. Temperature very carefully, because if the goal of doing this process is preserving each of your three components, you need to be writing this down, Robert. If the goal of this is preserving each of your three components, then if you let that AB mixture get up close, if you let it get to 110, which would be pretty easy when you're boiling, if you let it go a little too far, guess what's going to happen? You're going to start to lose A. So that's tough. That's a challenging, that probably requires a level of control that we don't have in a high school chemistry lab. That requires some slightly more sophisticated equipment than we would have on hand. Did anybody take a different path? Okay, so ethanol?
No.
Okay, ethanol is the alcohol that humans consume. Ethanol is also the alcohol that is brewed from corn and added to most fuels at 15% by mass. So what if we mix this with ethanol and filtered it? Does that change what we get out? Of course it does, or I wouldn't be having this conversation. We get B and C in the ethanol. I'm just writing F. Yeah, B and C are both soluble in ethanol. We get A and ethanol in a filter. Is there any advantage to this over the other two methods? So again, this is a good one if we want to preserve all three components of the mixture. If we need for some reason to save each of the three components of the mixture, this works better. Is there any advantage? So here's something you might not know about ethanol. Its vaporization point is about 80, I'm going to make up a number. I'm going to say it's 86. It's somewhere between 85 and 90 degrees Celsius. It's lower than water. That's how we can distill water out of ethanol. So if we heat, we'll say it's definitely lower than 90. We heat at 90, we should be able to get rid of the B and C. What does that give us here? Gives us a little more leeway between drying that A and driving it off as a vapor. So there might be an advantage to that. We're done with A. We've got A separated. It's in a filter. It's dried. How do we separate B and C now?
Water.
Now we would use water. So we would be doing a double filtration. We would filter dry, mix, filter dry, mix, filter dry. It's a little more cumbersome. Vaporizing your A is certainly easier. It saves you a whole step because you don't have to do a double filtration. Either other pathway is going to require a double filtration. But are any of them wrong? No. They're all legitimate ways to do this separation. There are multiple pathways to achieving the end. The only question you have to ask is, do I need to preserve all of my components by the time I'm done? Okay, sure. So here's a temp timeline for any substance. Until every molecule of that water has vaporized, your temp's going to hold at 100 because all the energy in the mixture is being devoted to liberating water molecules from the liquid phase to the gaseous phase. So until every last bit of water is dry, you're not going to see the temperature of the mixture rise to 112. Now, what I said about being really careful here, you may have portions of the mixture, here. So when you guys did your separation and you were starting to heat your salt water, were all parts of that the same amount of dry at the same time? No. If you've got solid that's up on the container sides, that's going to heat differently than the solids that are down in the bottom that are still kind of muddy. So your idea is not totally off base, but there are some physical constraints that would go with it. If you were doing sort of a really fast and dirty separation and you weren't too particular about loss, that might not be a bad technique. But for a little bit more refinement, you would probably want to do, if you want to preserve them all, you have to do double filtration. There's no way around it. Okay, I realize that on 10-minute delay schedule, we're going to run out of time. Here's what's going to happen when you walk in tomorrow. You're going to have a FIP quiz when you walk in tomorrow over doing physical separations. Then we're going to start to talk about the application of this in real life, because we're really talking about, whoops, nope, that's not where I wanted to go. We're still talking about this. We're still over here. We're still talking about mixtures. And I guess thinking about your method, Jeremy, with the, all-in-one step, if it was a completely homogeneous mixture throughout the process, that would work pretty well. If it was heterogeneous at all, if we had water and substance A that were not evenly distributed, is where you would run into losing substance A before all the water boiled off. So, okay, questions, comments, concerns? You guys did a good job. Like I said, 3 different ways to get there. It's all a matter of elegance and what you have to keep.